Hello there, student. This is an introduction to the Certified SolidWorks Professional Examination. This is just going to be a brief introduction and overview of all of the features that you may need to know that you might not already know. So, the SolidWorks exam has three major parts. The first part is where you make a part and you just change it. So it's going to be 10 or so questions where you make one or two parts, you change the dimensions, and then you just give them the mass. The second part is they're going to give you a part that has many configurations in it. Then using the design table, you're going to modify this part and give it whatever mass or center of mass properties it needs. The last part is assemblies. You're going to create an assembly. They'll either give you parts or you'll make several parts. You'll put it together and use several advanced features in order to modify the assembly. Now let's get into all the features that you're going to need to know for this exam. First, you'll need to know how to make a sketch. So sketches are very, very simple, and I'm sure you know it. You have circles, rectangles, arcs, you know all that. But what you might not know is something called a center line. So if you go under the line tool here, you can click something called a center line. Now what a center line does is it's just something you can use to constrain geometry. So say I want to have a circle that was over there. I could dimension these center lines. Yep, just like that. And then even if I extrude it, the center lines don't get extruded. It's just the one sketch that gets extruded, not the center lines. So these are a very important tool that you should be using to constrain your sketch geometry. Now I'm going to show you some of the more advanced sketch tools, which are offset, convert, and trim. So let's start with trim. So trim is a very useful tool because what it does is it can delete parts of a sketch, but not all of the parts. So let's say I want to make a little weird cone thing like that. I don't know. So I have this, right? And so right now if I tried to extrude it, see, it doesn't work. And the reason it doesn't work is because there's this line here that intersects these two bodies. So what I do is I have to get rid of just this line. So to do that, we use something called trim. So if you go to up here, trim entities, then power trim is selected, what you do is you can click and drag over things you don't want, and it just gets rid of it. It's very easy to do. So then you can extrude this really easily. Yep, now it extrudes just fine. Now let's go to offset. So let's say I want to have a little brim around the edge there. So what I can do is I can make another sketch here. Then I can do something called, what I can do is I can do convert and an offset. So I can click convert entities. Then because I want just this whole face, so I can just click this face, click the green check mark, and now we have a sketch on this plane that's exactly the profile of this face. Now we can do offset. So I can select all of these, offset, and so what this does is it takes the line and it offsets them by a certain amount. So if we want to offset 5 millimeters, you can choose direction here. You can make it go both directions. I just want to do it this way. So green check mark, and now we have that little brim thing. Then I can extrude that. Yep, and now we have that thing right there. And that's how you do offset, convert, and trim. Now you probably know about sketch relations. So here are a list of all the sketch relations in SolidWorks. There's horizontal if you want 2 points to be horizontal, vertical if you want them to be vertical, collinear if you want two lines to be directly in line with each other, corradial if you have two arcs you want them to be essentially part of the same circle, perpendicular if you want two lines to be perpendicular, parallel, concentric, tangent, you got that. So then to add constraints in SolidWorks, what you can do is you can go up here, add relation, then you can select two lines, right? Then I can make these tangent, which I've already done already. Or easier, you can just click one line, hit control, click, while holding control, click on another line, and it just brings up all the available constraints you can add here. Next is the sweep tool. So sweep, you'll probably never have to use it, for this exam at least. It's a useful tool, but it's just not super essential, but I'm going to show you how to do it anyway because Daysalt says that it's covered in this exam. So what sweep does is it takes a profile like this square, then you make another sketch that shows where it moves. So this is useful if you want to extrude something that's not necessarily straight. So say if I want to make this go around that curve there, I can do that with a sweep. So you go to features up here, swept boss / base. Then you need two parts. You need this part, which is the profile that's being swept, and this thing, the profile that is being swept around. So I can click that. Yep, and now we have an essentially extrude that's in the direction that we specify. Next is the loft, which is also a tool you probably won't have to use, but I'll show you how to do it anyway. So loft, what it does is it takes two different sketch profiles and essentially it connects them. So you can use this to make all kinds of weird shapes that you might not necessarily be able to make with normal extrusions and cuts. So what I'm doing here is I'm making a sketch on that plane. Then what I want to do is I want to make another sketch on a plane that's far away from it. Okay, so see how I have these two squares, one below and one up high. So I go up here, loft / base. Then you select the profiles, so I can select this one, and I can select this one also. And so it basically connects them. You can also have guide curves. So say if I wanted this to be kind of like not straight up and down like that, you could add like curves or anything to define how these two profiles are connected. Next is the fillet and chamfer. This is probably a tool that you've seen before. It's pretty basic and it's very useful for making parts. So up here, fillet, and below it is chamfer. So fillet, it makes edges round. You can select the face, you can select edges, and you can, over here, you can define the radius of the fillet. Just like that. Then you also have chamfer, which unlike a fillet, which is rounded, a chamfer is flat. See, it's flat like that. So you can determine the length of the chamfer, and you can also set the angle. This is important because some of your parts in your exam might not have a 45-degree angle, it might be something like a 30-degree angle. So depends on what your question is. Next is the draft tool. So I'm sure you've heard of drafting. Drafting is very important when you're actually making parts for like injection molding or whatever, because you can't like injection mold something that isn't straight. So what drafting does is essentially extrude something at an angle. So say we have this little rectangle there, and we extrude that. So right now it goes straight, right? Very straight lines. Let me make it bigger so you can see. Yep. So what we can do is this feature right here, that's the draft. So you click draft on off, then you can set the angle of draft that this part has. So let's say I can make it like something stupid like a 10-degree angle. As you can see, it drafts inwards. You can also make it draft outward, something like that. It's unlikely that you'll see this in the exam, but it's possible, so that's how you do it. Next is the shell tool. So say we want to make this part kind of hollow, which I mean, I don't know why you'd want to do that, but it's possible you would. So up here is something called the shell tool. So first you want to select what thickness of walls you want to have. So let's say I want 1mm wall thickness, and I select one face that'll be open, I select that face, and we can show a preview. So what it does essentially is it makes this face open, then makes the rest of it have that 1mm wall thickness. Like click green check mark, yep. Now we have that kind of like vase sort of thing. Next is the hole wizard feature. So hole wizard is something you actually use in the exam. Right here on the left I have a sample exam that's in the document that goes over everything else you need to know for the exam. And so it tells you exactly what kind of hole you need to use for the hole wizard. So to use hole wizard, it's up here in features, hole wizard. And let's see, it wants an anti-metric counterbore. So anti-metric counterbore. And we need a hex bolt, yep, that's the one. Size, we need an M8. Fit, close. So yeah, just basically change all these settings till they're exactly what we want. Then let's see what else. Oh, so it looks like it wants us to change some of these constraints. Yeah, which is kind of strange, but whatever. So it wants this is the through hole diameter, we want it to be 15. We want the counterbore diameter, we want that to be 30. Counterbore depth, we want that to be 10. And it doesn't specify anything about the angle, so we can probably leave that the same. And then we want end condition, so instead of making that blind, we make that through all. Yep, so now we have all of these settings, so we go to positions, And you can just kind of, so first we need to select a face that we want this hole to go on, so I'm just going to select this face. Then it just kind of puts that in there. So then, once you have that one hole down, you can hit escape to get out of the hole selection. Then we can go normal that surface, and then we can move this all around. So this is a great place to use the construction lines we used earlier. So if we want that hole to be like centered on this rectangle, what we can do is we can select this midpoint, click on this dot, coincident. So now this hole is exactly centered on this rectangle. Hit green check mark. Yep, and now we have that hole on there with exactly those dimensions that they specified in the examination. Next is the linear pattern. So let's say I want to have multiples of this hole all over this face. So instead of putting down multiple hole wizard things, I can just use a linear pattern to make this feature go all over. So you go linear pattern up here, and first you select direction. So I want to go this direction. You can just select any edge basically, and then you just select the features we want. So you can have features to pattern, faces to pattern, or bodies. So I'm going to select features, then I'm going to go up here to the feature tree, and I'm going to select this counterbore hole. So I select that. Yep, and then you can constrain how many you want, so 3 sounds good, and the spacing between them. So I'm going to go with 40, that looks about right. So now I have 3 holes on this part exactly like I wanted, and they're equally spaced from each other. A circular pattern is just like a linear pattern, only in a circle. Who would have guessed? So to get the circular pattern, let's right under linear pattern, then circular pattern. So first, the direction. So it's a circle, right? So we just want to select any circular profile, like that one. You can select an edge, a surface like that. You can do a lot of things. Then we want to select what features. So I'm going to select this rectangle I made earlier, because I want a lot of those. Yep, so then just like the other pattern, you can select how many you want. So this right now is set to equal spacing. So for over 360 degrees, which is the whole circle, we'll have 3 of them. You can also set them to be each one around 15 degrees apart, but I like equal spacing, so I'm going to have like, I don't know, 50 of them. So now we have 50 of those things equally spaced along this circle. Next is equations. Equations are probably the most important part of the first exam, if you don't know them already. So this is the sample exam, and it wants us to make this part here. And so notice how some of these dimensions aren't actually dimensions. There's letters, like C, B, C, all of that. And then over here it tells us exactly what all these letters are. And some of them have equations, like x is a divided by 3. So we want to put this in SolidWorks. So what we go is we go to Tools, we go to Equations. So now we can add our equations in. So we're going to do, technically it's not equations, it's global variables. So if we're going to put global variable A, I'm going to hit tab to go to the value of such equation, and A is 213 millimeters. Yep, and then we can do B, 200 millimeters, and we just go down the list. And then if you want to add an equation like this one, you just put equals, and you go to global variables, A, and you just put divide by 3. Yep, it's that easy. Then Y, and global variables, this one is B, divided by 3, plus 10 millimeters. And so the reason that we put equations in like this is because in later parts, it'll ask us to change these values. So this is part 2 of that same problem, and it wants us to make A 225 and B 210. We'll right click manage equations, and we can just change them. So A, we can make that 225. And then if we've made our part right, the part should automatically change. And then to actually add these dimensions to the part, so let's say we have a rectangle here, like that, and we want to make this side length A or whatever, so we go to smart dimension that. Yep, so that. Then you hit the equals sign. So you go equals, then this pops up. Then you can just constrain this to be global variables A, just like that. And so this equation sign means that it's related to an equation, and you can modify its dimension by going in there. Next is the mirror tool. You've probably used this one before. So it's basically just if you want this thing, you could mirror it around any surface basically. So mirror, so right here, mirror, you can mirror a lot of things. You can mirror features, bodies, faces. So I'm going to select this face, mirror, sure. Features, I'm going to select this boss extrude and this boss extrude. I'm going to select both of them. And yep, Now I have it just like that. For a SolidWorks exam, how you enter your answers is you enter the mass of the part that you've made. So, if say this is our part, to add mass what we want to do is we want to first add a material. So we go right here, edit material, and then it'll give you a material that it wants. It'll always tell you exactly what material it is. So say our material is this, or whatever. And it's always a good idea, it'll also give you the mass, so it's a good idea to make sure that the mass of the material you're using is right. So if it'll specify like 8,000, this is 8,000, we're good to go. So we add our material, then to determine the mass of the material, we go to up here, evaluate, mass properties, and then it'll tell you exactly what the mass is. So let's say, so that's what the mass of our part is. You can also change the settings, so if it asks for the mass in kilograms, you can change it to kilograms, milligrams, you can also change the number of decimal points. Now we're moving on to design tables. So design tables are an important and valuable way to make configurations. So what it does essentially is it links all of the dimensions and features that you want into an Excel table, which you can use to configure them later. So to add a design table, go to Insert, Tables, Design Table. You'll need to have Excel on your computer to use design tables. All of the Cane computers have it, so that's not a problem. It's just if you're using like a personal computer or something like that, you need to be aware. Alright, so the sidebar's opened up. You have the options, blank, auto create. Just hit green check mark. And so now we have our table open here. So how this works is that this column is are your configurations, and this column are your features and dimensions. So to add stuff to this column, you just kind of click on parts here. So let's say I want to configure this dimension and this dimension. And you can just so when you click on parts of the body in your SolidWorks thing, it opens up the sketches. So you can just configure these dimensions, everything like that. So I can call this one default, original, and I can call this one new. And I can change all these dimensions to be whatever I want, whatever the new part has to be. And so then it'll make a new configuration with those specified dimensions. So I click anywhere outside of that table, and then it'll generate that. Yep, so now it's generated the following configurations. So then over here, this is this is your feature tree. Then the third tab is your configurations manager. So you click on that, then I can click on my new configuration. Then it will modify the part to match its new dimensions. Yep, so it's modified the part that's matched new dimensions. It's broken it a little, as you can see, but it has those new dimensions as I specified. And if you ever want to edit your table, you can go to table here, design table, and you can edit the table. Here's an example of a very sophisticated design table where they are making compression springs. So they have the wire diameter, the dimensions, and then they can make any size compression spring they want using this table. As you can see, there are a lot of different ones. So when you take the actual exam, you don't have anything this complicated. You just have 4 parts. You might have changed dimensions. You can also suppress and unsuppress features in the design table, and you can change the appearance of the parts. Suppressing a feature is very easy, and basically what it does is it takes a feature, gets rid of it, but if you want it back, it's really easy to get it back. So let's say I don't want this pocket here anymore. So I can go to its original feature, cut extrude to, I can right click, and this here is suppress. So I suppress it, now it's gone. See, it's not there anymore. Then I can do value enhanced properties, and then this will be the mass of the part without that pocket there. But let's say I change my mind. I want that pocket back. I go right here to the cut extrude to, unsuppress, and it's back, just like that. Oh, one thing about the suppressing is it suppresses all of its child features too. So I don't know if you recall, but there used to be a fillet in all these corners here. But because that was related to that cut extrude, which I suppressed, that fillet is still suppressed. So we have to go to that fillet, which I believe is this one. It's one of these. Probably this one. We can unsuppress that. And there we go. That fillet's back. Now I'm going to show you how to make an assembly and the basic mates you might need for the exam. So first, you create a new assembly, and you'll have to insert one part. So take your base part, like this one, and I always just the green check mark to put the first part down. That's just the easiest way to do it. So then we can put in our other part, so we go to Insert, Component, existing part. Then we can add in the other parts it gives us, or whatever parts we've made, anything, whatever the exam wants. So we can insert all of our parts, just like this. Yep, and now we can mate them. So for this part, I want this thing to be concentric with this hole, and I want this face to be coincident with this thing here. So we go to mate. First I can select concentric, this surface and that surface, just like that. And now I can select coincident, this face and this face. Now those are coincident, and now this thing can freely rotate around here, just like that. So now this part is a little more complicated, because I want it to be exactly centered on the face of this cube here. So first I'm going to do coincident with this and that, just like that, but I want it to be perfectly centered. So to do that, I'm going to use something called a width mate. So width mate is very simple. What you do is you select 2 widths and 2 tabs. So I can select 2 faces of this cube, and I can select these 2 inside faces right here. So now these 2 blue faces are perfectly centered around these 2 purple faces. So I can hit the green check mark, select width again, and then I can do the same for the vertical faces, just like this. So I select 2 width and then 2 tabs. Yep, and now this cube is fully defined and is perfectly in the center of this other part. So now I'm going to show you how to do interference detection. Interference detection basically tells you if there are parts in your assembly that are hitting each other. Simple as that. So let's say that I took this part and I moved it over that little nub there. So now as you can tell, this nub is inside this lever here, and there's interference in our assembly. So to prove that, we can go to Tools, Evaluate, Interference Detection. Then we can hit Calculate, and it'll tell us there is interference there. So this is a question you might get on the exam, because it's very important if your parts are interfering with each other, because that affects manufacturing and whatnot later on. Now I'm going to show you how to make a coordinate system in a SolidWorks assembly. So a coordinate system is important because the answer for each question is the center of mass of the part. And because of the center of mass, it matters a lot where you're measuring the center from. Right now, the coordinate system is this point on the cube, right there. And so, if I want to put the coordinate system right on that part right there, what I can do is I can go up here to Reference Geometry, Coordinate System, and I can select where I want it to be. So for that, I can select this point at this corner here. Then I can select what I want the axis to be. So I can make this line the x-axis, I can make this line the y-axis, I can make this line the z-axis. You can do basically anything you want. You can change the orientation of all these. Now I have the coordinate system right there. And then when I go to Evaluate Mass Properties, see there's the center of mass, but it's important, they have to change the report coordinate values relative to here. You have to change it from default to coordinate system 1, which is the new coordinate system that we made. So now this is the center of mass relative to that corner there instead of to that corner there. The last thing I want to show you is reference geometry. So you can make reference geometry in parts or assemblies like these. So all it is you can make a plane. So if you've taken Calc 3, you know how to make a plane. You need like a point in the line, a plane in the line, 2 parallel lines, anything like that. So the same rules apply here. So you can select, I can select this plane here. You can make it that distance off. You can make it perpendicular to that plane, and you'd have to select like some other point or whatever. It's just like Calc 3 essentially. So if I select that line, that point, I got a plane right there. You can also select make axes, where you can basically just select any like circular surface like that, and even axes, just like that. It's very basic. So that covers all the features that should be in your exam. I recommend you do the practice exam, which you should have, which will take you through segment 1 of the exam. And I recommend you play around with some configurations and assemblies just to get a feel of those. You'll be ready for the test. That's all I have. Good luck.